Alright, in section 9, we're asked to graph each angle in the coordinate plane. So we're doing a reference angle. In here, number 35, we have 4 pi over 3. Well, if you're not sure what 4 pi over 3 is equivalent to, you can always multiply by 180 over pi, do a little conversion. And because it's being divided by 3, it's a multiple of 60 degrees. So it ends up being 240 degrees. So you may find that a little bit helpful, at least in the beginning, okay, until you get familiar with radians versus degrees again. So we start at the positive x-axis, we go counterclockwise, 240 degrees. And I'm just going to put on here that our reference angle would be 60 because 240 minus 180 would be 60 degrees. And that's going to come in handy in the next portion of our work, where you're asked to find the exact trig value. So we would have the side opposite 30 would be negative 1 because we're going in the negative direction. Side opposite 60 would be negative square root of 3, and the hypotenuse would be 2. Number 36, negative 5 pi over 6 would convert to negative 150 degrees. So again, we start at the positive x-axis, but we go clockwise. So it's going to take us into quadrant 3. And our reference angle would be 30 degrees. So across from 30, we get 1, but we're in quadrant 3, so it's going to be negative 1. This side would be negative square root of 3 and 2. Again, just putting that reference angle in there for the exact value questions later on. Pi over 4, it's a quick one. That's equal to 45 degrees. So that's going to be halfway between 0 and 90 in the first quadrant. And it is the reference angle. So the sides are equivalent. So 1, 1, square root of 2 for that special right triangle. Negative 5 pi over 4, it is a multiple of pi over 4, so it's a multiple of 45 degrees. 5 times 45 is 225 degrees. That's going to put us, well, it's negative 225. So make sure you start at the positive x-axis. There's negative 90, negative 180, and then negative 225 degrees. Reference angle is still 45, so this side would be negative 1, positive 1, square root of 2. Okay, 5 pi over 3, that's a multiple of 60, like we saw in number 35. It is 300 degrees, so that's going to start again at that positive x-axis, going all the way around to quadrant 4. So reference angle would be 60, because we only need 60 more degrees to make it 360. So we are going to have 1, negative square root of 3, and 2 for the sides in that special right triangle. Last one, 11 pi over 6. So it is a multiple of 30 degrees. So 11 times 30 is going to give us 330 degrees. It's positive, so start at the positive x-axis. 330 degrees only leaves us with 30 degrees more to go to make it one complete revolution. So the special, the reference angle is 30, so the sides would be negative 1 across from 30, square root of 3, and 2. Okay, next we're going to use those special right triangles to find exact value. Okay, so now for finding the exact value. So with number 41, we have the sine of 4 pi over 3, which is equivalent to the sine of 240 degrees. The first thing you want to do is, draw your arrow to indicate the direction. It's positive. We're in quadrant 3, and in quadrant 3, only tangent and cotangent are positive. So remember the phrase, all students take calculus, to help you remember which trig functions are positive in which quadrant. A refers to the fact that all trig functions are positive in quadrant 1. The S means that sine and cosecant are positive in quadrant 2. T tangent and cotangent are positive in quadrant 3, and the C in quadrant 4 means that cosine and secant are positive if the angle's in quadrant 4. Okay. For number 41, again, we are in quadrant number 3. Our reference angle is 60 degrees, so I've drawn a special right triangle. We're doing sine, so sine is equivalent to opposite, which would be negative square root of 3. That's the side opposite our angle, and 2 is the hypotenuse. So our final answer would be negative square root of 3 over 2. Okay, for number 42, our equivalent angle was negative 150. That puts us in quadrant 3 again. Cosine is negative in quadrant 3. Cosine is adjacent over hypotenuse, so it will be negative square root of 3 over 2. Okay, number 4, we're taking a look at tangent of pi over 4. Tangent is opposite over adjacent. So our tangent value is 1 over 1, which is just 1. Okay, for number 44, cosecant is it's the cosecant of negative 5 pi over 4, so negative 225. Cosecant is the inverse of the sine function, so sine would be opposite over hypotenuse, so we want to take hypotenuse, square root of 2, and put it over 1, so just be the square root of 2. Okay, number 45, the secant of 5 pi over 3. Secant is the inverse of cosine, so it's equal to 1 over cosine. So cosine would be adjacent over hypotenuse, so we want to do hypotenuse over adjacent, so 2 over 1, or just 2. And finally, for the cotangent of 11 pi over 6, or cotangent of 330 degrees, that's just the reciprocal of tangent. Tangent would be negative 1 over the square root of 3. So this will be the square root of 3 over negative 1, which is negative square root of 3. Final answer. Okay, in section 11, we are completing the trig identities. So the reciprocal identities, as I mentioned in the previous questions, we did cosecant, and it's 1 divided by the sine of theta. Secant is 1 over cosine theta. So secant and cosine are reciprocal identities, and cotangent is 1 over tangent theta. Our quotient identities, tangent is equal to sine theta over cosine theta. Cotangent is equal to cosine theta over sine theta. Okay, Pythagorean identities. The most important one for us to know is sine squared theta plus cosine squared theta equals 1. These others are helpful too. 1 plus tangent squared theta is equal to secant squared theta. And finally, 1 plus cotangent squared theta is equal to cosecant squared theta.